Hello and welcome to this repair tutorial, and today a little bit different. We're going to look at a CD player and the model number is NAD C542. This unit was released around about 2004 for sale in the UK, and then in terms of general specifications it's supporting both CD, CDR and also CD-RW compatible discs. For the decoder HDCD it has automatic detection. It also has the Burr-Brown Sigma Delta 24-bit digital to analog converter. Frequency response is 5 Hz to 20 kHz plus or minus 0.5 dB. It supports both a coaxial digital output and optical digital output, as well as the connections via the rear RCA for the analog output. Output impedance is 150 ohms. Output level at 0 dB is 2.2 volts RMS. The CD player would have been provided with a remote control from new, so if you're looking to support a replacement, you're looking for the NAD CD6. And then dimensions, height, width and depth, 70mm by 435mm by 285, and the weight of the player is 4.1 kilograms. Now before we sort of get into the issue and the reason why this CD player came in for service, what I want to do first off is just to walk you through the block diagram, and this is of course an extract from the service manual. If you look at the left hand side towards the top, this section here is covering the power supply, and you can see that there are multiple voltages which are generated. So the first ones are the plus 8 volt supply, plus 6 volt. We then have the analog power, which is plus 12 volts, minus 12 volts, and then also plus 5 volts. And then finally we have this minus 22 volt supply. And the reason why I'm mentioning that is that this CD player required a complete recap, and you'll see later on in the tutorial really how these capacitors within the unit had degraded over time. And they were branded capacitors, i.e. Japanese manufacture. And then here you have the keyboard, and you can operate the CD player of course without the remote control if you wish. And then you have this dedicated micro, and that provides the interface to the keyboard. You can also see the vacuum fluorescent display. You also have the trigger input as well. We've mentioned this on other tutorials where you can connect multiple units and then just have a single trigger input, hence the relays that you see in the power supply section. And then it also supports the NAD link as well. So again, if you had other NAD devices, you could interconnect them if you wish. You can also see the remote center for the remote control, and then that goes to the NAD link microcontroller. And then you also have the trigger input going directly into that CPU. And then on the left hand side towards the bottom, this is where you have the mechanics of the CD player. So you can see the optical pickup, and then you have the pull-in limit switch. So this is where it will do the detection and then of course feed that signal back. And it's very important with anything like a CD player, or it could be a VCR, that you have the required switches and they must close in a certain time period. And then on the motors you have the sled motor, spindle motor, and then you can also see another one of these switches, which is the loading switch, and then also the loading motor. Now, when this CD player was taken apart, really in exceptional condition, so there was service work carried out on the mechanic side of the CD player, but really it was just to remove some dust. Didn't really see any sort of degradation with regard to the plastic gear mechanism, and the lens assembly was also cleaned. And then if you look to the right from the digital signal processing IC, you can see the digital to analog converter. And then you can also see the output from the DSP going also to the digital output side, so that being the coaxial and also the optical output. And then here if we take a closer look, you can see the extract here is from the power supply section, and you can see in more detail. Now with this CD player, as I mentioned, it required to have all of the electrolytic capacitors replaced. But it wasn't that the CD player wasn't working, it's just that the owner of the CD player felt that it was probably time for these capacitors to be renewed. And the brand of capacitors is by two manufacturers. The majority of them made by ELNA, and then the other one, Nichicon or Nichicon Gold. And you see the data sheet will specify that, more associated with the audio processing side of the CD player. And then what you found was that all of these capacitors really had gone low in value, and a lot of them had gone high in ESR or equivalent series resistance. Now the reason why I emphasize this point about this power supply is that here you have different levels of loading. So when you are driving motors for a CD player, of course motors will require a amount of current, and if the smoothing capacitors are deteriorating, then they're not going to be able to perform as well as what they would have done when the unit was new. Also as well, when these electrolytics start to fail, after rectification, part of the function of an electrolytic is to remove low frequency noise. So here, a 100 Hz ripple when it's been fully rectified from AC. And the last thing that you want is that ripple entering into any part of a digital circuit, because it's going to create havoc. And of course, we know from repairing audio amplifiers, again, you don't want any noise coming directly into any part of the audio signal processing. And then here in a little bit more detail, I'm not going to spend any time on this. What you've got here is a microcontroller. And if you reference back to the block diagram, you can see the keyboard assembly at the top where it's reading directly the input from the user, and then all of the associated inputs coming in. Now, remember that this is a microcontroller, so it would have been flashed, i.e. the firmware embedded into the unit during production. Now, when we take a look here from the top of the CD player, you can see the various electrolytic capacitors. So these are these Nichicon Gold capacitors that you see there. And then the main power supply section, which is on the left-hand side, and we'll take a bit more of a detailed view in a moment, is where you see these ELNA capacitors. And then if we just zoom in slightly, you can see here in more detail all the different capacitors. And there's approximately 45 capacitors that require to be renewed. And then here you have the small toroidal transformer. And then when we look at the power supply section, you can see the multiple fuses for protection. And what I've done is I've just disconnected it from the toroidal transformer. And all of these capacitors, as I said, was reading very, very low in capacitance value, and also ESR was very high. Now there's another point that we need to mention, and this is what you're seeing in this photograph here. And this is the vacuum fluorescent display. Now, of this era, early 2000s, really you saw these vacuum fluorescent displays on pretty much most consumer electronics. For sure they were in VCRs, CD players, etc. And what you can find is over time you get oxidization within the filament of the displays, and that results in a dimming effect. Now, you could attempt to maybe apply some degree of over voltage to try and clean off that oxidization, but of course, because it's like a filament wire, you have to be very careful, because if you apply too much current and you burn out one of the filaments, then effectively the display then is no longer usable, and unfortunately you can't source new displays. Now, the level of brightness on this display, it was reduced in comparison to what it would have been from new, but there's a number of things which you can do to just try and improve it. The first one, of course, is to clean the front of the display, because over time it will accumulate a lot of dust. And then at the rear, where you have the viewing window, again, that should be cleaned. What you also found was, because the power supply capacitors were low and high ESR, once those were replaced, you actually saw an increase in the overall brightness of the display. You can see here that this is one of the capacitors on the ESR meter. You can see that it's displaying that it's in circuit stroke, it's a leaky capacitor. And this capacitor, I think, was about 470 microfarad. And you can see that the ESR is around 6.1 ohms, so it's increased. And then here we show another example, and this is one of the smaller ELNA capacitors. So this is a 10 microfarad 50 volt device. And all these capacitors are rated at 85 degree operational temperature as well. And then here you can see that we have another capacitor, and although the ESR was fairly low at 0, what you found was it was half its value. So this is one of the Nichicon Gold capacitors. But when you look from the top of the capacitors, there wasn't any sign or anything like that. The capacitors were bulging, but of course as soon as you put them onto the ESR meter, then you saw the issue straight away. And then finally, we've shown you another example of a capacitor. And you can see here ESR around 7.30 ohms, and then at the top probably more than 55% of the capacitance value had been lost. So once all of those capacitors had been replaced, and I'm showing you here, the CD player then went through a full functional test. What I'm showing you on this photograph is the collection of 45 different capacitors. So in terms of how long would this take you to do, well, the work probably to replace all of these capacitors is around about 2.5 to 3 hours. And then, of course, you've got to take care of the mechanism of the CD tray and just make sure everything is good from that point of view. It's not really a case here that you have issues with dry solder joints. It's probably what you would on some other consumer electronic devices. But while the circuit board was out of the CD player, of course, those connections around where you have mechanical stress, the optical and then the RCA connectors was all checked. But there wasn't any requirement then to reflow or anything like that. And then here finally what we show you is the CD player on test, and then you can see that the vacuum fluorescent display is clearly visible. And then the only last thing to do is just to give it a thorough clean, but again there was no sort of dampness inside of the CD player. One thing which was replaced was the mains power plug. What I did find on inspection was that when I removed the protection fuse, you could see some mold or green which had gone around some of the metal parts. So rather than leave that or even attempt to clean, I just put a brand new plug on, and that just ensures, from a safety point of view, there'll be no future issues. So that sort of brings us to the end of this tutorial. So I really appreciate you stopping by, and if you need any help, guidance or assistance, by all means email Audio Amplifier Servicing at AOL.com, and I'll be more than happy to come back and provide any support that you may require. So until the next time, I wish you all the very best. Cheers and bye-bye.